Students, welcome to Perla Tutorials, Chapter 8, Motion, Part 2, Exercise Solutions. Question 1, page 112. An athlete completes one round of a circular track of a diameter 200 meter in 40 seconds. What will be the distance covered and the displacement at the end of 2 minutes 20 seconds? So let's start for the answer. Here, the diameter of a circular track 200 meter is given. So suppose we have this circle. Now the diameter, we know that from this point to this point, suppose we give it x and this point we give it y. So the diameter is 200 meter and the radius will be 100 meter. That is half of that. So we know that the radius now. Now the time taken by the athlete for a one round, that is 40 seconds, and the distance, as we know that this is a circular motion of the athlete. So whether it start from the x and it continue with this motion and again continue with and come to the one round. Okay. So the circular motion. So we know that the circumferences of the circle, that is 2 pi r. So we will put the pi is equal to 22 upon 7 and rest of the data, that is r is equal to 100. So what we will get, that is the distance. Now speed of the athlete, that is we know that the distance upon time. So distance we have calculated is given to us. We put data the distance. Time also we know. What is the time for the one round? That is 40 seconds, which is also we will put here. So we will get the distance covered in 140 seconds, that is speed into time. Okay. Why speed into time? This 140 second is there because we have the time which is given us, this 2 minutes 20 seconds. Okay. So this 2 minutes 20 second we will convert, because 1 minute is the 60 second. So 2 minutes 20 second will be the 140 seconds. So distance covered in 140 second, that is speed into time, because we know that speed s is equal to distance upon time. So we need to cover the distance, so we have speed into time. Got it? Now here, so we get the distance covered in 140 seconds, 2200 meter. So we got the distance, that is 2200 meter for the 2 minutes 40 seconds. Now we want to find out the displacement at the end of 2 minutes 20 seconds. So whether it starts from the x, so it will reach to the y. This is the distance. We know this displacement is the shortest distance. Got it? Now we know that the number of rounds, that is 40 seconds, it completed one round. In 2 minutes 20 seconds, how many rounds he will complete, that athlete? So we will divide 140 by 40, because we can say that in the 40 seconds athlete completes one round, then 140 seconds, how many rounds? Got it? So we know that by cross multiplication we will get 140 upon 40. So we will get 3 and 1 half. 3 and 1 half round. 3 full, 1 half, half round. That is, can say. So one round, this is one round. Second round, third round, and half round, that is from X it will reach to Y. This is the half round. Okay. So from this to this it will reach. So the displacement will be X is equal to, from X it will reach to X to Y, means XY. We need to calculate, or we need to take the displacement from X to Y, that is XY total. Okay. So that is why the displacement of the athlete from the position, hmm, from the position, respect of the initial position, that is initial position the athletes have X, now it is reaches to the Y. So displacement will be the X is equal to XY, and we know that the, what is the displacement we have, that is the diameter, so we'll have 200 meter. Okay. So we'll reach to next questions. Now again, Joseph jogs from one end to the other end. Okay. At a straight 300-meter road in 2 minutes 30 seconds, and then turns around and jogs 100 meter back to point C in another 1 minute. What are Joseph's average speeds and velocity in jogging from A to B and A to C? Now here, see, total distance from A to B, that is 300 meter, which is given to us, because first he start from here and reaches to here, so 300 meter it is given to us. Now the total time taken for this, that is 2 minutes 30 seconds, so we have to convert 2 minutes, minute is equal to 1 minute is equal to 60 plus 30 seconds, so we'll get 150 seconds. Got it? So we got the time and also the distance total. Now average speed, that is the total distance upon total time, that is we know average speed, that is total distance upon total time. So we have total distance 300 meter and total time 150, so we get 2 meter per seconds, that is the average speed. Okay. So we got the average speed of the Joseph. Now from A to B that we got, and from A to C we also have to find. So velocity also we have to find the velocity from A to B, that is displacement, because it is also said that the velocity also you have to find. So A to B we find the speed average, and now velocity. So the velocity, what is the velocity? That is the displacement upon time. So we have a displacement A to B, that is the displacement. And what is the time? The time, which is 150 meter per seconds. Okay. So speed and velocity here in this case will be the same, 2 meter per seconds. So that means it is going the uniformly straight line. Now again, one more thing which is asked here, that A to C velocity and the same we have to average speed. Now the time taken from A to C, as you can see, the time taken from A to C, what will be there? That A to B plus again it reaches to BC. So this time and this time, this total time we have to calculate over here. So A to B time taken plus B to C time taken. So total time taken 210. How 210? Because 150 is already for A to B. 150 is given for A to B, and from B to C it takes 1 minute. So plus 1 minute is equal to 60 seconds. So we will get 210 seconds. Got it? So we get the time. Now the time is there. Now average speed, that is total distance upon total time. Now what is the total distance? We know that AB is the 300 meter and BC is the 100 meter. So total will be 300 plus 100, that is the 400 meter. Okay. So total distance and total time we got. So we will get the average speed. This is the average speed we have. Now velocity, that's the displacement. What is the displacement? Now AB and the AC we have to find, that A to C. So the AB minus BC, then we will get AC only. Okay, so AC if you want, then we have to, from AB we have to subtract AC distance. So we will get that also displacement. So that displacement will be 200 meter. This is the 200 meter. So time taken for displacement from AC, that is we have 210, and velocity for this, the displacement, which is we have 200 meter, and time total, which is we have 210. So we will get 0.952 meter per second. Okay, so next for the move for next question. Now Abdul, while driving to school, computes the average speed for his trip to be 20 km per hour. On his return trip along the same route, there is less traffic and the average speed is 30 km per hour. What is the average speed for Abdul's trip? Let's check. See here, we know that the distance Abdul computes while driving, that is from home to school. Home to school. Suppose we will take it as. And time taken for this will be T1. From school to home. From school to home, that is also speed S. And the time taken for that T2. Okay. So distance Abdul computing while driving from school to home, that is also S, and time also T2 as I said. Now average speed from the home to school, that is given. That is given, home to school speed we have 20 km per hour, and school to home, that is 30 km per hour. So we can now calculate the time taken from home to school, that is distance or the speed or the and time. Okay, so time taken we have here, we know that, that is T is equal to S V up S upon V1. Here the speed is given. Okay, okay, as we know that V is equal to distance upon time. Yes. So here T1 and T2, what will get? T1, that is S upon first average speed, and T2 S upon second average speed. So now time taken, that is total time taken, that is we have S upon 20 plus S upon 30. Got it? So here is S upon 20 plus S upon 30. The LCM of 20 and 30 will be 600, and we have S plus S, that is the 2S, and we solve this thing, we will get to 24 km per hour total distance. Okay. Now question 4. A motorboat starting from rest on a lake accelerates in a straight line at a constant rate of 3.0 meter per second square for 8 seconds. How far does the boat travel during this time? Initial velocity. See, we have initial velocity, that is 0 because starting, so it will be 0. Now acceleration is given to us, that is 3 meter per second square. Time under consideration which is given, we have t is equal to 8 seconds. Okay, so we know that distance is equal to ut plus 1 half at square. So the distance traveled by a motorboat, if you put the data, you will get 96 meter. So move on the next question. Let's see. Question 5. A driver of a car traveling at 52 km per hour applies the brakes and accelerates uniformly in the opposite direction. The car stops in 5 seconds. Another driver going at 3 km per hour, another car applies his brakes slowly and stops in 10 seconds. So plot the speed versus time graph for the two cars. Which of the two cars are traveled after the brakes were applied? Farther travels. Okay, we need to find that. Okay, see, as given, this is the graph. Okay, where SQ SQ are the, this is the SQ. This is speed time graph we have just drawn. Now here the two cars with initial speed 52 kilometers and 3 kilometers respectively, they have given to us. Okay, first what we have to find, that is the distance traveled by the first car before coming to the rest. That is first car area, we know that is OPR. This is the area, first car, OPR. This is the area for the first car. Got it? So now area, we know that 1 half base into height. 1 half base into height. Base we have, that is OR, and height we have OP. Okay, so what is the data we have? We have OR is 5 second, and because it's the time which is given, we have 5 second OR, and OP which is given to us, that is 52 kilometer. Got it? OP which is given to us is for 52 kilometer. Here it is given to 52 kilometers. So by solving this, now kilometer per hour is given to us, as I told you earlier classes, that always put 5 upon 18 to change this kilometer per hour into meter per second. So we'll convert this in the meter per second. So we will get our answer, that is 36.11 meter. Now for the second car, the distance traveled by the second car before coming to rest, that is, we have OSQ. Here you can see OSQ. So I can say it for you, this OSQ. This is the shaded part we have to calculate. OSQ. So again we have same thing, 1 half OQ, which is base, and height, which is we have OS. OQ is given, that is O to Q 10 second. Yes, that is 10 second which is given to us. And height, that is speed, that is 3 kilometer per hour, which is also given to us. So this is the way we can calculate our same way. So if you know the triangle, the base of the triangle, area of the triangle, so you can calculate this question answers easily. Move on the next question. Same page, 112, question 6. Figure 8.11 show the distance time graph of three objects A, B and C. Study the graph and answer the following question. Okay, question 1 is which of the three is traveling the fastest? So here if you can see this is the B, this is the C, and this is the A. If you see, the slope is for the B is bigger, comparatively bigger. Slope of the B is comparatively bigger than the C and A. And we know that the faster means what? That is the speed of the object and distance upon time. Okay. Here the speed of the object depends on the slope. The bigger the slope, faster the object. So we can say the speed is the distance upon time, and here the slope of a graph, which is we have, this is y-axis, this is x-axis, and the slope of the graph, as per the graph, the distance upon time, the speed of the graph is slope of the graph. So slope of the B is greater than the object A and C. So it is traveling faster. As you can see, this is a bigger slope. Now B. Are all three ever at the same point on the road? So here you can see this is the B, this is the C, this is the A. But none of the car or none of the object reaches at the same point. They meet at some place, but they three of them are not reaching to the same points, is it? So no object is there, so the answer will be no for the B. Now C, how far has C traveled when B passes A? So as you can see here, this is the graph for the C, question C. Now here you can see C travels from here, this is the C. The origin point is 0. Origin point is 0. And C travels from here. And here if you check as per the graph rules, the 0 is the origin point and 4 coming here, that is 4 kilometer here. So as per the graph rule, the columns which are we have, or the square 1 2 3 4, whatever the square which are between O and 4, how many squares are there? So there are 7 square box are there. That means 7 square box is equal to 4 kilometer. Okay. From 0 to 4, we have 7 square box. That means the in between these are the 7 boxes are there, small boxes. So this is 4 kilometer. Now the starting point of the C is, C start after 4 blocks. This is the starting point. This is the 0 and this is the starting point of the C. So after 4 blocks is starting from here, 4 blocks. That means the origin of the C is 4 multiply 4 upon 7. So that will give us 16 upon 7 kilometers. Now distance of a C from origin when B passes A. So distance of C, what is the distance of the C? When B pass A, here is the B, it passes A. So you can see here, when it passes A, this is the place, it is 8 kilometer. Okay. When it passes A, it is the 8 kilometer. Now, the distance traveled by C when B passes A. So distance, when we have to calculate this distance, when B passes A, what is the distance traveled by C? So what we will do, we have the distance of C when B passes A, that is 8 kilometer. That is 8 kilometer is we have. and we also have distance from the origin. This is the origin of the C. So we subtract 8 from the origin, we will get the distance traveled by C. Okay. So when the distance traveled by C, when the B passes A, that is B 8 minus 16 upon 7. So we will get 5.714 kilometer. Here it will be the distance. This is the distance. 5.7 kilometers. Okay. Now, question D. How far has the B traveled by the time it passes C? So distance traveled by B the time it passes C. Here also the D is the graph which is given for you. Now same things. The D, we have the B by the time it passes C, distance traveled by the B when it passes the C. So we can say that the 9 square box, this is the 9 square box, okay, which is multiplied with the 4.7, because one square box is the 4.7. So B passes 9 square box. Okay, if you calculate here, there will be the 9 square box will be the pass by the B. So we will get what? This is 9 square box will pass by the B. So we will get 9 multiply 4 upon 7, that is 36 upon 7. We will get 5.143 kilometer. So move on to next question. Now here a ball is gently dropped from a height of 20 meter. It is if its velocity increases uniformly at the rate of 10 meter per second square, with what velocity will it strikes the ground? After what time will it strikes the ground? So let us assume, now here the answer. Let's check the answer. What is the, it says to us, let us assume the final velocity with which a ball fall strike the ground, that is v, and time is t. Okay, here the initial velocity will be 0, as we know that, and distance or height of the fall that is given, that is 20 meter, and the acceleration is also given, that is 10 meter per second, which is given. Okay, acceleration downward acceleration, that is 10 meter per second square. So we have the equation 2as is equal to v square minus u square. Putting all the data, we will get the velocity of the ball. Now according to the first equation of the motion, v is equal to u plus at. So we need to find out the time. Now we had completed the velocity. The velocity is 20 meter per square. Now we need to find the time. I hope you understand how this 20 meter comes. See, v square is equal to 400. So v is equal to 20 square, and this is square goes. So we will get v is equal to 20 meter per second. That is the velocity we are going to have in the answer. Now after that, what we have to find? The time. So the first equation of the motion we have is v is equal to u plus at. So t is equal to v minus u upon a, and what we'll get? We'll get 2 seconds. After what time will it strikes the ground? That is 2 seconds. Next question. Now the speed time graph for a car is shown here. Find out how far the car travels in the first 4 seconds. Shade the area on the graph. Okay. That represents the distance traveled by the car during the period. Okay. Let's see how it is. And second, which part of the graph represents the uniform motion of the car? A. The shaded area which is equal. Now here this is the shaded area we have. So you can see here, this is the triangle. So what is the area of triangle? That is 1/2 base into height. The area of triangle. Now what is the base here it is given? You can see in this triangle, that is the base is 4. So we have 4. Okay. And height is 6. Okay. This is the height, that is 6. So 1/2 base into height. So what we'll get? 12 meter. Replace the distance traveled by the car in the 4 seconds. Okay, fine. Now what? The part of the graph, what we have, which part of the graph represents uniform motion? So here you can see the graph. Just I make you a visible for this graph. See, here you can see this is the graph. Where the uniform motion? So from 6, this is the 6. From 6, it goes continuously, no change. That is the uniform motion. This is the uniform motion. This area, if anybody says you shade the area which is the uniform motion, so you can shade this area with the uniform motions. Let's move on the next question. Page 112. State which of the following situations are possible and give an example for each of these. So first it is given an object with a constant acceleration but with a zero velocity. Is it possible? Yes. When a ball is thrown up, when you throw the ball upside at a maximum height, this is the maximum, it has the zero velocity. As we know that when it is reaches here, it is the rest position, that is zero velocity. But what will have acceleration? As we know that this is the gravity. So the gravity have the constant acceleration, and that is 9.8 meter per second square. Second is an object moving in a certain direction with an acceleration in the perpendicular direction. Yes, possible. How? When a car is moving, suppose this is the car here, this is the circular motion. If I draw this and moving in a circular track, this is the car is moving continuously, suppose. Okay. So in acceleration is perpendicular to the directions. Yes, when this car moves, the acceleration will be the perpendicular to the its direction, that we understand now. Second question, that is 10 number. An artificial satellite is moving in a circular orbit of a radius, it is given. Calculate its speed if it takes 24 hours. Now the same way, this is the radius, it is given, that means circular motion, this is given. Now radius is given to us, this is 42250 kilometer, that is also we know that. And speed of the circular moving object, that is we know that. Distance upon time, distance we have what, that is the circular circumferences of the circle, that is 2 pi r, that is 2 pi r circumference circle. And the time is given, we have the time, so time is 24 hours. So after putting all this data in the respected manners, you will get the answer that the speed 3073.74 kilometers. So this is the solutions. If anything you have the problem, you can write in the comment box. Thank you for watching.